Let's look at how we can put two data sets and two graphs on the same set of coordinate axes using the Vernier program LoggerPro. Now this requires a common independent variable like the volume of titrant. We use this to show conductivity and pH as functions of the amount of sodium hydroxide being added. If you're doing this with two different independent variables, you really can't do this on LoggerPro or Merely. I can tell any other program. We're going to start with a titration of sodium hydroxide into hydrochloric acid. And as you can see here, we are graphing the drops of sodium hydroxide titrant being added against the conductivity. Don't worry about all those significant digits there, because almost only a couple, three of them are in fact significant. And you can see we start off with a typical V-graph, conductivity versus the volume of sodium hydroxide added. We also have a pH titration here using LoggerPro. You can also move this over from Excel or other spreadsheets. And as you can see, we have the same volume of sodium hydroxide, and the pH has been given to us by the computer program. And you can see the typical S-curve here. What we'd like to do is put this data onto the other one of our spreadsheets. Now, the easiest way to do this is to simply go over back to the original untitled program, and we can add a new set of data. So we're going to click on Data and add a new manual column. We type in pH, and the short name is pH, and of course pH has no unit, so we ignore that, and we click on Done. And that gives us a brand new, completely blank set of lines here to put our data into. We come down here to our original pH information, and we click on that graph, and all we have to do is paint this out, press Control-C to copy, or you could go up and you know how to copy things. And then we can go back to the program where we're merging our data and just paste it right in there with Control-V or an insert function. Now, it is also possible, if for instance you have your data in your laboratory notebook instead, you can just type the pHs in here. If you don't have a perfect correspondence between the drops here, for instance, maybe you skipped a drop, or you maybe we're doing it 2, 4, 6, 8, 10. Again, you can always just come back and add a line in, skip one of these numbers here, and you'll still get a graph. However, as you see, we don't have a graph. So what we're going to do is we are going to insert a new graph. And there's our pH. And you say, yes, but we haven't merged the graphs. Here we will we'll work on doing that next. Now, in putting both sets of data on one set of coordinate axes, first thing I'd like to do is just make this additional graph bigger. And then we're going to right-click on the graph itself and bring up our graph options. Now, we have two things that we can do in terms of just this, and we can title the graph if we wish to. So, merged pH and conductivity. And then we're going to go here to axes options, and that's the important thing here. The label we put here is pH titration, and now we're going to add a right y-axis, and we're going to call this conductivity titration. You may have to go back and fix that. What we want to graph is the conductivity here, and that just adds to the pH. The top of this, if we look at the pH, the top is going to be a 12. No, this is the conductivity. So the top conductivity here, we're going to call that 1,000. And let's see how that works. We're going from 0 to 15 on the x-axis. Let's see what we get. Well, sure enough, we now have a merged pH and conductivity here. The pH titration on the left goes from 1 to 12. The conductivity goes from, in this case, 2, but it really doesn't start until up here about, let's see, 100, 200, about 230. And then it goes up to 1,000, so it gets all of our points in. And now you say, well, how about lines? So we want to find the equivalence point. Therefore, just as we would do if the graphs were separate, we paint out the data we want to put a straight line on, kind of like that. And then we go up to our linear tool, and we are going for the conductivity here. So we click on that, and we've got our straight line for our declining conductivity. And then we click outside that, and we grab our lowest data and come over here on the ascending portion of the curve. We click on our linear tool for conductivity, and now we've got these two things. Let's move these equation parameters out of the way so we can see everything. And now you say, oh, the equivalence point is going to be right here. Fine. What about the equivalence point that's somewhere in this void in the pH titration curve? Well, we really can't do exactly what we want and show us a second derivative with this data. If we had a second derivative, we could plot that instead of the actual pH, but we like that pH curve. It's kind of a cool little curve. So one of the things that we can do, since we're using, in our case, a strong acid and a strong base, is realize that the pH at the equivalence point with strong acid, strong base, the pH is 7 because there's no hydrolyzable salts. So if we paint out just these 3 points here, and we click on the linear tool, and we choose the pH titration, now we've got a straight line. The best fit straight line through these points is going to be very close to when we're at 7. So let's go over here at 7 point. I'm looking down at the bottom left, and you see those numbers are changing. Let's see about 7. There we go. 6.18 is the number of drops. And down here we have the intersection point, which is the equivalence point using conductivity, 5.80. Now, these are not always going to agree. We're using two different methods. The drop sizes may have been different. But now we have our equivalence point volume for the conductivity and for the pH, 6.16. And now we can use those volumes in our volume of acid times molarity of acid equals volume of base times molarity of base equation to calculate the molarity of whatever it is we're looking for, acid or base. I hope this has been helpful to you.